So in this video I'd like to go over matrix assembly using lookup vectors. So it's a lot like assembling load vectors, but with matrices we just extend the lookup across 2 dimensions. Okay. So on the left over here I have KFF, which is a 3x3 matrix. I'm keeping the matrices small just to make the screen manageable. But this of course extends out to much larger matrices. Okay, but this is a 3x3 matrix. You know, this is column 1, 2, 3, and then row 1, 2, 3. Okay, and over here on the right I have 2 element matrices, which are say 2x2. This is element 1, which has 1, 2 degrees of freedom, and then 1, 2 degrees of freedom there, and then this is its lookup vector, which maps into the structural degrees of freedom 1, 2, and 3. So it has 1 and 3. Okay, and then element 2, also 2x2, okay, has different entries, and the lookup vector is 3, 2. Okay, so on the left, the KFF matrix, I just went ahead and put some values into this matrix, all right, such that we can show how these 2 elements, or the stiffness matrices of these 2 elements, assemble into KFF with something pre-existing non-zero. Okay, so with the lookup vector of 1, 3 for element 1, this goes to 1, 3, and that goes to 1, 3. Okay, so this entry, the 1, 1 value, is going to map into the 1, 1 value for KFF. All right, so we're going to accumulate 3 into the existing entry of KFF, so this will become 13. Okay, and then for this entry here, all right, going down the columns, all right, you can go across the rows or down the columns, either which way you want to go first. All right, but we have -1 for this value, and this is going to map into row 3, column 1. Okay, so row 3, column 1 in this matrix is this entry. Okay, so we're going to add -1 to 8, all right, and this will become 7. Okay, likewise, this -1 goes into row 1, column 3. Okay, row 1, column 3 goes to this 8. Everything's symmetric here just for similarity to what you see in structures, all right, but this will become 7 as well. We add a -1 into 8, and then this 3 goes into row 3, or column 3, row 3, which will be this entry here. Okay, so 25 plus 3 gives us 28. Okay, let me change colors here. Let's go with too many choices. All right, let's go with blue. All right, so for element 2, all right, the lookup vector is 3, 2. All right, so this local degrees of freedom 1 and 2 map to structural degrees of freedom 3 and 2. And that goes to 3, and that goes to 2. Okay, all right, so this 5 goes from 1, 1 for the element into row 3, column 3 for the structure. Okay, so we take this 5, we add it to the current entry of KFF 3, 3. All right, so 28 goes to 33. Okay, and then row 1, column 2 of the element goes to row 3, column 2 of the structure. All right, so this goes here, and this goes from 2 to 4. All right, we add 2 to the existing entry of 2, it becomes 4. Okay, so row 2, column 1 of the element goes to row 2, column 3 of the structure. All right, for this entry, and this will go to 4. Okay, and then this 5 down here goes into row 2, column 2, or excuse me, column 2, row 2 for the structure. Okay, which will be this entry here. All right, so this goes to 25. Okay, and then we repeat this for all the elements All right, and then the final KFF that we would have, I'll just rewrite what we have here. 13, -3, 7, -3, 25, 4, 7, 4, 33. Okay. All right, so note that we started with KFF symmetric. We assembled into it 2 symmetric element matrices, so the resulting KFF after the assembly should also be symmetric. All right, it's a good sanity check. All right. So with that, we'll conclude this video. But also note that if we had negative lookup values for the elements, i.e. the elements connected to constrained degrees of freedom, say L, let's just do another matrix. This was, say, another element, -1 and 2 were its lookup values. Let's call this element 3. Sorry, I guess I wasn't done. All right. This is, say, 4, 4, 1, 1, whatever it is. Right? Okay, this would go -1, 2, -1, 2 for the lookup values. Okay, so where we have -1 when we assemble into KFF, we can just ignore that column. It's not going to go into KFF. We'll use it when we assemble reactions, right, for the constrained degrees of freedom, but for unconstrained degrees of freedom, it's not going to be important. Okay, then when we get here to degree of freedom, structural degree of freedom 2, all right, mapped from the element. Okay, we see that for this column and then this row, we have a negative value for the lookup there, so we'll just ignore that one. And the only contribution we'll have into KFF is going to be from element 2,2 into structure 2,2. Okay, the lookup value, or the degrees of freedom match for this lookup value. All right, but hopefully that's not confusing. All right, but this 4 will be added into the current value there, and this will become 29. Okay, so with that, I am in fact done, and let me know if you have any questions. Thank you.